All right, homework 10, problem 4. So in this one, we want to find what's the momentum of a photon having a wavelength of 2.5 microns. So momentum of a photon is just h over, let me use math mode, it's h over lambda, right? And so h is 6.26 times 10 to the minus 34 joule seconds. And lambda in this case is 2.5 times 10 to the minus 6 meters. All right, so 6.626 e minus 34, 2.5 e minus 6. The ratio of those two, the photon momentum is 2.65 times 10 to the minus 28th. Kilograms meter per second. Okay, that's part A. Next, find the velocity of an electron having the same momentum. Right? And so velocity of electron first, relativistic momentum, right, is P equals gamma mv. And so this, if it's not relativistic, is approximately mv. So let's first take a whack at seeing whether or not this is relativistic or not by simply going with the velocity is the momentum divided by the mass, right? So we've got the momentum here of 2.65 times 10 to the minus 28th kilograms meter per second divided by, and the mass of the electron 9.109 times 10 to the minus 31 kilograms. Well, that looks silly. Okay, so let's find out what this is. So 9.109 e minus 31 kilograms. So we got a velocity of this momentum divided by this mass, 291 meters per second. 291 meters per second. This tells us this is by no means relativistic, right? So when we get to question C, and it says what is kinetic energy of the electron, we just use the classical kinetic energy equation, right? 1/2 mv squared. So this is 1/2 of 9.109 times 10 to the minus 31 kilograms times the velocity, 291 meters per second squared. All right. So 0.5 times the mass of the electron times the velocity squared is 3.86 times 10 to the minus 26 joules. 10 to the minus 26 joules. All right. And how does this compare to the energy of the photon? Well, the energy of the photon is HF, is hc over lambda. All right. So the energy of the photon is 6.626 times 10 to the minus 34 joule seconds times 3 times 10 to the 8th meters per second, right? All divided by lambda, which is 2.5 times 10 to the minus 6 meters. Okay, so we have the energy of the photon is h times c divided by the wavelength. Energy of the photon 7.95 times 10 to the 20th, 10 to the minus 20th. 7.95 times 10 to the minus 20 joules. So in this case, a photon with the same momentum has much more kinetic energy than an electron with that momentum. And this is because the electron actually has mass. And that's it for problem 4.